So let us discuss about limit comparison test. So what limit comparison test says, if ratio of an over bn, if ratio of an over bn is constant and it is strictly positive, then you can say that the summation an and summation bn have the same behavior. It means either both convergent or both divergent. And we know why it happens, because an it becomes a constant multiple of bn after large stays. It means definitely if one sum is finite, definitely another sum is also finite. If one sum is infinite, then another summation is also infinite. And yeah, when it comes to the statement 2, if you see that they are saying that here limit is 0. Limit n goes to infinite, an over bn equal to 0. It means what? So if the limit is 0, it means what? Given an epsilon greater than 0, we know that there exists a space n such that the distance between the sequence and the limit becomes less than epsilon, right? So this implies what? Absolute value of an over bn is less than epsilon. So this implies modulus of an is less than or equal to epsilon times modulus of bn. Okay, now this clearly says, now you can actually take comparison result now. So the summation bn is the bigger summation, right? So if the bigger summation is finite, definitely the smaller summation is also finite. So in that way we can say that if the limit is 0, if you know that summation bn is convergent, then summation an is also convergent. That's what we can say. Okay, and similarly for infinite. So if the limit is infinite, so if limit n goes to infinite, if an over bn, if this is infinite, it means what? So you can actually say that um, an over bn is becoming larger and larger and larger. So whatever m value you take, this an over bn can become larger than the taken value. Okay, so it means now I can actually see it like this. This is an greater than of m times of bn. So now if this summation is divergent, okay, and it is below an. So if this summation is divergent, definitely I can say that this an is divergent. I mean the summation an is also divergent. But we may not conclude the other way. Why? Because here you have some constant multiple. The constant multiple, I mean this constant is not a fixed constant. It depends on the stage. Okay, so that's why we all will only conclude one way here. So the conclusion is that if the limit is infinite, then if summation bn is divergent, then summation an is also divergent. So now we need to think. Okay, we need to apply limit comparison test here to know whether this series is divergent or convergent. Okay. So first let me rewrite it like this. This is 1 plus n times of ln of n over n squared plus 5. Okay, now we need to decide. We need to decide Bn. So to decide Bn, let's do one thing. Let's try to see it like this. The entire expression I can actually see it as n times ln over n squared. So how does it look like? Ln of n over over n. That's it. Okay, so the suitable choice of Bn, which is going to be ln of n over n. So now let us try to find out the limit of an over bn. Let us try to see. So limit n goes to infinite. So an over bn, that is limit n goes to infinite. you'll get 1 plus n ln of n over n square plus 5 times n over ln n, because the reciprocal of bn, right? All right. Now, but if we take this, is it easy to compute the limit? Instead of taking ln n here, so let's do one thing. We feel like the summation is divergent, so we can actually start with any sequence which is divergent, which is relatively close to this one. Okay, so bn, instead of taking ln of n, instead of taking this, so what I want to do is I want to change my bn. So I'd like to update bn to be 1 by n. Okay, so in that case, what happens? Then in the denominator, I simply have 1. That's it. Okay, so now this is limit n goes to infinite, and this will be what? I hope it will be n plus n square into ln of n over n square plus 5. So I hope now you can go with L'Hospital rule. So if you apply L'Hospital rule, what do you get? Because in the numerator and denominator, we are getting infinite over infinite. So let's go to apply L'Hospital. So in that case, it becomes 1 plus 2n into ln n plus n square times 1 by n, this over 2n plus 5. So 5 derivative would be 0. Okay, even now it is looking like infinite over infinite form, so let's try to apply it one more time. So when you apply it for one more time, so limit n goes to infinite, you'll get 0 plus 2 into ln n plus 2n times 1 by n, and here n square by n will cancel, so you'll have only n, the derivative of n is 1, whereas in the denominator we will have 2. Okay, so now if you plug in the value, if this n cancel, you'll get 2, so 2 plus 3 you'll get here. So as n goes to infinite, I hope we can see that it is of the form infinite by 2, so therefore it is infinite. So if you observe that limit of an over bn, we got infinite. Okay, so when you get infinite, if summation bn is divergent, then only we can conclude that summation an is divergent. But what about summation bn? So here if I take summation bn, so this is what we get. Limit n goes to infinite, an over bn, it becomes infinite. It means that summation, if summation bn is divergent, conclude summation an is also divergent. What is summation bn here? That is summation 1 over n. And we know that this is divergent. Okay, so this is divergent. Therefore, by limit comparison test, so we can conclude that summation an, that is summation 1 plus n times of ln n over n square plus 5. Okay, and this is divergent. So when you get infinite, if the limit is infinite, we can only conclude about divergence, and that too if summation bn is divergent, then only summation an is divergent. Okay, so here are some problems for which let's try to apply limit comparison test. I hope in the morning we did this problem, sine of 1 by n. Okay, so now I'll take this problem n, and it is easy to pick up bn in limit comparison test. సో హియర్ సో ఇప్పుడు మీరు యాక్చువల్గా ఏం చేస్తారంటే n లార్జ్ అయినప్పుడు జనరల్గా మనం ఏం చేస్తాం n+1 ని n లాగా ట్రీట్ చేస్తాం, అట్లాగే n+2 ని సో అలా ట్రీట్ చేసినప్పుడు సో ఇది దేనికి ఈక్వల్ ఉన్నట్టు సమ్మేషన్ జస్ట్ 10 బై డినామినేటర్ లో వచ్చేసి n. సో ఇది ఏమవుతుందంటే సమ్మేషన్ 10/n² అవుతుంది. ఓకే, సో ఇప్పుడు మనం bn ఏం తీసుకుంటే సరిపోతుందండి. సో an వచ్చేసి గివెన్ సిరీస్ టర్మ్ ఉంది. ఓకే, సో ఇప్పుడు మనం bn వచ్చేసి అక్కడ మనకి 10/n² అని వచ్చింది కదండి. సో 10 అవసరం లేదు, జస్ట్ 1/n² అని తీసుకొచ్చాము. సో ఇప్పుడు మనం ఏం చేద్దాం, లిమిట్ తీసుకోవాలి. లిమిట్ n goes to infinite an over bn, అంటే లిమిట్ n goes to infinite 10n+1 over n into n+1 into n+2 this times n² over 1. Okay, now we need to find its limit. So limit n goes to infinite. So I hope we can cancel this n² and n here. So we'll be left with 10n+1 in the denominator, not just 10n+1, 10n² plus n. And అక్కడ ఒక n మిగులుతుంది కదా, మల్టిప్లై చేసేది. సో ఇక్కడ ఏముంటుందండి n+1 into n+2. So again we can find infinite by infinite form. So just apply a L'Hospital. So applying a L'Hospital, you get limit n goes to infinite. In the numerator, you'll get 20n+1. In the denominator, we call it a multiply చేసాను డెరివేటివ్ చేయండి, డైరెక్ట్ గా చేయొచ్చు. ఓకే, సో మల్టిప్లై చేస్తే మనకి ఏమొస్తుంది n² plus 3n+2 వస్తుంది. So that derivative చేస్తే that becomes 2n+3. Again, I hope we can see infinite by infinite form. So again, apply a L'Hospital. So limit n goes to infinite. This would be 20 over 2. So we got 10. So the limit is 10. So it's positive. Okay. So we got limit as a constant. So using limit comparison test, we can say that both summation an and summation bn have the same behavior. Okay. And what do we know about summation bn? We know that summation bn, that is summation 1/n², is convergent. So since it is convergent, this implies that summation an is also convergent. That is summation 10n+1 over n into n+1 into n+2. This is convergent. Okay, so that's it. So the conclusion is that the given series is convergent. అంటే ఇదంతా చేయకుండా మీరు డైరెక్ట్ గానే చెప్పేసి కన్వర్జెంట్ అని, కాకపోతే డీటెయిల్స్ కావాలంటే ఖచ్చితంగా ఇదంతా చేయాల్సిందే. So now I'll do one thing. I'll try to write the possible bn's here. This one we did and this one we did. And here for this one, what do you think the bn is? Okay, for this problem, I hope we can take bn equals to 1/3^n-1. Okay, and of course this is going to be convergent. You can take apply limit comparison test. Okay, and for this problem, I hope we can see that 5n³ over n⁴. So n³ over n⁴. So you take bn equal to n². It will converge. And you know, for this, for problem number n, bn would be 1/n⁴ 1.1. ఎందుకంటే tan inverse n అనేది బౌండెడ్ ఫంక్షన్ అండి. And this one, secant inverse of infinite, so that gives you a finite quantity. What would be secant inverse of infinite? Can someone tell me? When secant theta will take infinite value? Yeah, so that's pi by 2. Okay, so here in this case you take bn equals to 1 by n power 1.3, and in case of t you take bn equals to 1 by n square, and you can find that cot hn limit will be finite. మీరు ఏం చేస్తారంటే cot hn ఇక్కడ రాయండి. Cot hn that equals to e power n plus e power minus n over e power n minus e power minus n. I hope you know the formula for sin hn and cos hn. So ఆ రెండింటిని డివైడ్ చేస్తే cos over sin you will get this. సో దీని లిమిట్ ఫైండ్ అవుట్ చేయడానికి మీరు ఏం చేస్తారంటే ఈ పవర్ అన్ని కామన్ తీయండి. సో ఈ పవర్ అని కామన్ తీస్తే న్యూమినేటర్ లోని డినామినేటర్ లోని ఈ పవర్ అని కామన్ తీసి క్యాన్సిల్ చేసేసారు. సో అప్పుడు ఏముంటుంది ఇక్కడ 1 మైనస్ ఈ పవర్ minus 2n over 1 plus. This is 1 minus e power minus 2. This is how you can write cot h. So as n goes to infinite, I hope you can see that it is 1 plus 0 over 1 minus 0. And e power minus 2n, 1 by e power 2n. And that will go to 0 anyway. Okay. And similarly, you can think about this problem. Yeah, the rest of the problem, I suggest you to do it. Okay. So, e problem ki em chestaru simple ga sum find out chesesi cheyandi saripothundi. So for this problem, meer em cheyali sum of first and natural numbers formula undi kada, n into n plus 1 by 2. So adi ikkada vesi danni cheyali. Like sum of squares of first and natural numbers, n into n plus 1 into 2n plus 1 over 6. That formula you need to write here. Okay. So this is about comparison test, limit comparison test. Okay. Now I want to discuss another test to check the convergence or divergence. And of course, this is coming two tests are going to be the last test for convergence of say divergence of the series. Okay, so here what we will do is, given a sequence summation an, assume that where each an is positive, okay, strictly positive, not even non-negative. Okay, so now we will take limit n goes to infinite, that's an plus 1 over an. This is what we will take. It means we will take the ratio of n plus 1 term and n term. So if this ratio becomes L, assume that this ratio limit becomes L. Okay. So L అయిందంటే ఇప్పుడు an plus 1 over an, అంటే ఒక స్టేజ్ తర్వాత ఏమవుతుంది, ఇది L కి ఈక్వల్ అవుతుంది అంతేగా, ఫర్ వెరీ వెరీ లార్జ్ n. సో దీన్ని ఇట్లా రాయొచ్చు కదండి ఇవి కానీ an plus 1 equals L times an. Now this implies, so an plus 2 ఎట్లా రాస్తారు, an plus 2 equal to same L times an plus 1. But you know what is an plus 1? An plus 1 is L times an. That is L times an. So the ఏమైంది ఫైనల్ గా L square into an అయింది. So next term చూస్తే an plus 3 L cube into an గా రాయొచ్చు. అలాగే నెక్స్ట్ అట్లా ప్రొసీడ్ అవ్వచ్చు. సో ఇప్పుడు మనం ఇన్ఫైనైట్ సమ్మేషన్ చూసాం అనుకోండి. సో ఇన్ఫైనైట్ సమ్మేషన్ ఎట్లా కన్వర్ట్ అవుతుంది, ఒక స్టేజ్ దాటిన తర్వాత, అంటే ఫ్రమ్ n plus 1 స్టేజ్ You can actually see it like a times L times an plus L square times an plus L cube times an plus and all. అంటే ఇక్కడ మీకు an అనేది కామన్ తీసేస్తే ఫైనల్ గా ఏమొస్తుంది L ప్లస్ L స్క్వేర్ ప్లస్ L క్యూబ్ plus and all. So what is this? This is nothing but a geometric series. Okay, and when this geometric series is convergent, and we know that this geometric series is convergent if it is convergent if and only if absolute value of L is less than 1. Anyway, we are taking the positive term sequence. So L is definitely positive. So no need of taking absolute. But one thing we can say, if L is less than 1, it is convergent. And we can also say one more thing. This is going to be divergent if L is greater than 1. Okay. And you may say one more thing. At L equal to 1, it is divergent. Fine. But we cannot conclude anything about this series. The original series. Okay. I'll tell you why. I'll give you an example. But let me show you the ratio test here. So it is called D'Alembert's ratio test. You see that? Let summation A be a series with positive terms, and suppose that limit n goes to infinite an plus 1 over an is L. Okay, the limit is L. And if this L is less than 1, then the series convergent. And if L is greater than 1, then it is divergent. Greater than 1 uchina, infinite uchina, divergent. And the test becomes inconclusive when L is equal to 1. Okay, so let's take a problem here. For example, the summation n equals to 1 to infinite. I'd like to take 2 power n over n power 2. I'd like to take this. Okay, is this summation convergent or divergent? So I would like to apply ratio test here. So nth term, what is nth term here? an is 2 power n over n square. But if you are clever enough, you can directly say that it is divergent. Why? Because limit of nth term is infinite here. It's not equal to 0. But anyway, let's do it by using ratio test. So if an is this, what would be an plus 1? That is 2 power n plus 1 over n plus 1 whole square. Okay. So now let's write this. Limit n goes to infinite an plus 1 over an, that equals limit n goes to infinite. I hope you'll get 2 power n plus 1. You can write it as into 2 over n plus 1 whole square times reciprocal of an, that is n square over 2 power n. Okay. Now I hope we can cancel something here. So this is limit n goes to infinite. So cancellations చేసేస్తే 2 into ఇది మిగిలేదు ఏంటంటే n into n plus 1 whole square. So you can write it like this. Limit n goes to infinite 2 into ఒక n కామన్ తీయండి. So numerator denominator కామన్ తీసి క్యాన్సిల్ చేస్తే వస్తుంది. So what is its limit? So limit n goes to infinite. This is actually 2 times. Okay, I can apply limit. Why to write limit again? So this becomes 2 times of 1 over 1 plus 0. అంటే ఏమొచ్చిందంటే 2. Okay. So it means what? The limit is 2. And don't get the confusion between the limit comparison test and ratio test. So ratio test ఏం చెప్తుందంటే వచ్చిన లిమిట్ అనేది లెస్ దాన్ 1 అయితే కన్వర్జెంట్ అవుతుంది, గ్రేటర్ దాన్ 1 అయితే డైవర్జెంట్ అవుతుంది. ఓకే, సో ఇక్కడ మనకి లిమిట్ ఎంత వచ్చింది సార్? 2 వచ్చింది. సో యు నో దట్ దిస్ ఇస్ గ్రేటర్ దాన్ 1. ఓకే, సో therefore by ratio test the given summation, that is summation n equals to 1 to infinite 2 power n by n power 2, this is divergent. So greater than 1 వచ్చింది కాబట్టి ఇచ్చిన సమ్మేషన్ అనేది డైవర్జెంట్ అవుతుంది. Can we solve this by using comparison test? Yes, you can solve. See, it's like we are just trying with testing methods of convergence and divergence. Yeah, so if you want to apply comparison test here, let me do it here. So summation 2 power n over n square. So we're comparison apply చేయాలనుకుంటున్నాం కదా. సో నేను ఏం చేస్తా అంటే n square 1.5 పవర్ n. సో ఏది బిగ్ ఉంటుంది అంటే 1.5 అని రాసింది అంటే లెట్ మీ రైట్ ఇట్ as 3/2. So that you can 3/2 whole power n. I hope initially you may say this is bigger, but after some stage it will dominate definitely. So 1 by n square is going to be less than or equal to 1 by 3/2 whole power n. It is going to be 2 power n by 3 power n. So now we can say that 2 power n by n square is less than or equal to 2 power n over this is the 3/2 whole power n, and that equals to ఇది న్యూమరేటర్ లోకి తీసుకెళ్తే 4 power n over 3 power n అవుతుంది. అంటే ఇది 4/3 whole power n. అంటే సమ్మేషన్ n equals to 1 to infinite దీని మొత్తం రాస్తే మనకి 4/3 whole power n అవుతుంది. And this becomes divergent. So this implies that summation 2 power n by n square. So this is also divergent. Okay. అంటే ఇప్పుడు మనం ఈ ముందు చేస్తున్న ప్రాబ్లమ్స్ అన్ని ఓకే ఈ మెథడ్ ఐ మీన్ ఈ టెస్ట్ కే ఇది అప్లికబుల్, వేరే టెస్ట్ యూస్ చేసి దీన్ని చేయలేము అట్లా ఉండదు. ఓకే, వీ నీడ్ టు లుక్ ఎట్ ద పాసిబిలిటీస్, దట్స్ ఇట్. ఒక్కొక్కసారి లిమిటేషన్స్ ఉండొచ్చు. ఇప్పుడు 1 plus cos n over n square ఉందంటే అప్పుడు కంపారిజనే బెటర్. Okay, so now like we are taking the ratio here, right? So by seeing the ratio, if it is less than 1, we are concluding it is convergent. If it is greater than 1, we are concluding it is divergent. Okay, I'd like to go with just one more problem for this. Yeah. So let's pick up a problem from here. So let's try to do this. Hard work. Or 11. Which one do you want? 3 or 11? So let us apply ratio test here and try to see whether this summation is convergent or divergent. Okay. So here what is an plus 1? An plus 1 is n plus 1 times n plus 2 over, oh sorry, I'm writing an. Okay, fine. So this is actually an. And how about an plus 1? So an plus 1 is n plus of plus 1, so that becomes n plus 2, and this becomes n plus 3 over n plus 1 factorial. Now let's take the ratio. So limit n goes to infinite, an plus 1 over an. So ratio just was the limit n goes to infinite. First we need to write n plus 2, an plus 1, that is n plus 2 times n plus 3 times n plus 1 factorial times the other. Okay, so now this equals, I hope we can cancel few things here. I hope we can cancel this and this, yeah, and then of course here this n plus 1 factorial, we can write it as n plus 1 into n factorial. So we can also cancel that. So now you are left with limit n goes to infinite. What is it? This is n plus 3. So ఇక్కడ న్యూమరేటర్లో అయితే n plus 3 ఒకటి మిగిలిందండి. ఈ n ఫ్యాక్టోరియల్ పోయింది, క్యాన్సిల్ అయిపోయింది. ఇక్కడ ఈ ఫ్యాక్టోరియల్తో క్యాన్సిల్ అయిపోయింది. సో ఇక్కడ ఒక n plus 1 ఉంది, ఇంకొక n plus 1 ఉంది, కాబట్టి n plus 1 whole square. And what is its limit? I hope you can see that. Okay, you may if you want you can go with one more step. It's like infinite over infinite. So you just find the limit of it. Limit n goes to infinite. Take the derivatives. That is 1 plus 0 over 2 times of n plus 1. Okay. So now I hope it's easy to see that its limit is nothing but it's a kind of 1 over infinite. You can see it. Okay. So it is 0 means, is it less than 1 or greater than 1? And it is less than 1, right? So let's write the final conclusion. So the final conclusion is limit n goes to infinite, an plus 1 over an, which is equal to 0, and you know this is less than 1, therefore given series is convergent. Okay, so given series becomes convergent. Yeah, so now I'm taking an which is equal to k power n after large space. Okay, so if it is equal to k power n, suppose if we list out the summation here, this looks like this, and it is a geometric series, and you know that it is convergent only if k is less than 1. Now if you want an to be like this, like k power n, then what is the condition on an? Like an whole power 1 by n must be equal to k. Okay, so here let's try to derive the condition. So limit n goes to infinite, which is an whole power 1 by n. Okay, if this is k, the limit is k, and we can say that this, if k less than 1, then summation an is convergent. Like how we conclude in the ratio test. If k is greater than 1, then summation an is divergent. If k is equal to 1, then the test is in conclusion. K equal to 1, then it is in conclusion. So this is the ratio test. We call it as a Cauchy's nth root test. Why? Because you are taking nth root of an. And you see it? Let summation an be a series with a non-negative an for some natural number capital M, and suppose the limit of nth root of an is L. Then the series is convergent if L is less than 1, it diverges if L is greater than 1, and it is infinite or infinite, it diverges. So the test becomes in conclusion if L equals to 1. So let's try to solve a problem. So I'll pick this problem. Problem number 5. Okay. ఇక్కడ an వచ్చేసి ఏంటంటే an ఈక్వల్ టు n మైనస్ 2 బై n హోల్ పవర్ n, రైట్. సో ఇప్పుడు మనం రూట్ టెస్ట్ అప్లై చేద్దాం అనుకుంటున్నాం. సో లిమిట్ n గోస్ టు ఇన్ఫైనైట్ an హోల్ పవర్ 1 బై n తీసుకోవాలి. nth రూట్ అంటే లిమిట్ n goes to infinite n minus 2 by n whole power n. ఇది an. ఈ an మనం ఏం చేయాలి? whole to the power of 1 by n తీసుకోవాలి. Okay, and this becomes limit n goes to infinite n minus 2 by n whole power n by n. So you can cancel n and n, and we are left with limit n goes to infinite. So this is just n minus 2 over n. Yeah, the unlucky thing is here we are getting limit as 1. And you would get it right. Limit n goes to infinite 1 minus 2 by n. So limit ఏమొచ్చింది ఇక్కడ 1 minus 0 అంటే 1 వచ్చింది. సో 1 వచ్చినప్పుడు మనం ఏం కంక్లూడ్ చేయడానికి ఉన్నది అంటే టెస్ట్ యూజ్ చేసి రేషియో టెస్ట్ యూజ్ చేసి కంక్లూడ్ చేయడానికి ఏం రాదు మనకి. ఓకే, మరి ఇప్పుడు ఎట్లా చేస్తారు? సో yeah, that's correct. So now we'll go for nth term test. What is nth term test? We know that limit n goes to infinite 1 plus x by n whole power n. Its limit is e power x. Okay, so keeping this in mind, we can easily say that so limit n goes to infinite so an, that would be limit n goes to infinite. Here an it means 1 minus 2 by n whole power n, and this converges to e power minus 2, and it's not equal to 0. See, I'm applying nth term test here. Be careful. Nth term test. Okay, since the nth term is not going to 0, therefore we can conclude that summation an is divergent. It means, therefore, the given summation n minus 2 by n whole power n, this is divergent. Okay. Here are some set of problems and one more set is here. But okay, you tell me which problem to pick up. Let's start recording. Yeah. So here an equals to what? N cube over e power n. So I'd like to apply root test here. Nth root test. So that is limit n goes to infinite. So an whole to the power of 1 by n. So that is limit n goes to infinite. That is n cube over e power n whole to the power of this whole to the power of 1 by n. And this one can be rewritten like limit n goes to infinite n cube whole power 1 by n over e power n whole power 1 by n. ఎందుకంటే a by b whole power m ఉంటే then a power m by b power m గా రాయొచ్చు. Okay, and this equals limit n goes to infinite. So n power 1 by n whole cube. But it like change power. Okay, over e power ఇదేమవుతుంది end cancel అయిపోయి e power 1 వస్తుంది. Okay, and we already know that n power 1 by n limit is 1. Therefore, this is 1 whole cube by E. So what is it? 1 by E finally. So 1 by E, is it less than 1 or greater than 1? Is it less than 1 or greater than 1? Yeah, so it's less than 1, correct. So this is less than 1. Therefore, if it is less than 1, we know that the given summation is convergent. Therefore, summation n equals to 1 to infinite e power negative n times of n cube. This is convergent. That's it. So this is how you'll apply root test and solve problems. Yeah. From this set, you can pick one problem. We will solve that, and with that we will stop. So here is a question: n power 1 by n equals the limit of n power 1 by n is 1, right? So general గా అయితే చూపించడం అవసరం లేదు, డైరెక్ట్ గా చేసేయచ్చు ఇక్కడ. బట్ మీకు డీటెయిల్స్ కావాలి అంటే బెటర్ ఓకే, యూ కెన్ గో లైక్ దిస్. యూ టేక్ y ఈక్వల్స్ టు n పవర్ 1 by n. సో ln y ఏమవుతుంది? ln y becomes ln of n పవర్ 1 by n. ఇది ఎట్లా రాయొచ్చండి? l 1 by n అనేది ముందుకు వస్తే 1 by n టైమ్స్ ln n అవుతుంది. అంటే ln n by n కి ఈక్వల్ అయింది కదా ln y అనేది. సో ఇప్పుడు మీరు లిమిట్ అప్లై చేస్తే ఏమవుతుంది? ఇన్ఫైనైట్ బై ఇన్ఫైనైట్ ఫార్మ్ వస్తుంది. ఎలా వస్తుందో అప్లై చేస్తారు. ఇప్పుడు మళ్ళీ చేస్తే ఫైనల్ గా జీరోకి వెళ్తుంది. సో ln y కి జీరో కన్వర్జ్ అయితే సో y ఎక్కడికి కన్వర్జ్ అవుతుంది? ఈ పవర్ జీరోకి కన్వర్జ్ అవుతుంది. సో therefore n పవర్ 1 by n goes to 1. క్లాస్ లో చేసాం అనుకుంటా ఇది ఆల్రెడీ. So let's pick up 20. So what is an here? An is n factorial power n over n power of n square. It's anyway positive, so no issue. So let's apply nth root of it. That is a whole power 1 by n. So that's nothing but limit n goes to infinite. N factorial whole power n. This over n power n square. So this whole to the power of 1 by n. Now like earlier, we need to write it separately. That is n factorial power n. I'm writing it directly here, okay? N by n divided by, this is actually n power n square by n. Do you agree? 1 by n అనేది న్యూమరేటర్ కి డినామినేటర్ కి కూడా షేర్ అవుతుంది. సో ఇది ఏమవుతుంది? లిమిట్ n goes to infinite. సో న్యూమరేటర్ లో n ఫ్యాక్టోరియల్ ఉంటుంది, డినామినేటర్ లో n పవర్ n ఉంటుంది. Okay, now we need to see its limit. Okay, but directly finding the limit is not easy here, but we need to use some technique. The technique is n factorial over n power n, that equal to 1 into 2 into 3 into 4 and so on n. This over n into n into n into and so on n. Now, what do you think? Is the denominator dominates or the numerator dominates? Which one dominates here? Numerator? Are you sure? Okay. సరే, ఒక పని చేద్దాం. 5 factorial by 5 power 5 చేద్దాం. అంటే అది 1 into 2 into 3 into 4 into 5 అది 5 factorial. డినామినేటర్ ఏముంది? 5 into 5 into 5 into 5 into 5. ఏది పెద్దదమ్మా?
Denominators.
Yeah, so denominator dominates here. ఓకే, మీరు లేదంటే టర్మ్ బై టర్మ్ కంపేర్ చేసుకోవచ్చు. ఇక్కడ ఫస్ట్ టర్మ్ కి ఈక్వల్, కానీ నెక్స్ట్ బిఫోర్ టర్మ్ వచ్చేసి ఇక్కడ ఉన్న టర్మ్ కంటే స్మాల్. సో డినామినేటర్ డామినేట్స్. సో డెఫినెట్లీ దిస్ లిమిట్ వుడ్ గో టు జీరో. సీక్వెన్స్ లో దీని మీద ప్రూఫ్ కూడా ఉంటుంది యాక్చువల్గా. అది డిస్కస్ చేస్తానండి, వీలైతే నాకు వీడియో చేస్తాను. Prove that n factorial over n power n converges to zero. Okay, so the limit will become zero here. If the limit is zero, it means it is less than one. So if it is less than one, so what can you say about the given series?
Convergence.
Yeah, this is convergent. Therefore, by root test, we can say that this series is convergent. That's it. Okay. Yeah. So I'll stop it here.